Chapter 11, Gases. This is about gases and orange soda. How long is too long when making a long straw to drink soda out of? And you should read this section of the book, even if you don't read anything else, because this part's a little bit interesting. The author was very fond of making extra long straws when he was a child, and he'd like to make a straw and then stand on a chair and drink soda from a glass sitting on the floor, which you can imagine how that would appeal to some children. How long is too long, though? Could you make one that was, 2 miles long? Would it work? And exactly how does a straw work anyway? Well, when we suck on the straw, we remove some of the molecules from inside the straw, which creates a pressure difference between the inside and the outside of the straw. And then the soda is actually pushed up the straw by the atmosphere. Okay, there's air, right? There's miles of air above us, and it exerts a pressure. And it pushes down on the soda. And when we reduce the pressure in the straw by sucking the air out, that enables the atmosphere to push the soda up the straw. Well, it turns out even if you had a perfectly sealed straw, and the walls were rigid so they didn't collapse, and you were able to pull a perfect vacuum, the straw would not work if it was longer than 10.3 meters. Now granted, that's 34 feet, that's a really long straw, but still, you can't make one that would work that's any longer than that. So we're going to look at why that is. Well, what is pressure? I mean, we all know what pressure is. We mostly think of like stress, right? I'm under a lot of pressure right now. This is physics pressure. Pressure is the force exerted per unit area. So these gas molecules are moving and they collide. They collide with each other. They collide with the surface of the soda. They collide with the walls of the containers that they're in. They run into things. There's gas molecules hitting your body right now, and it's exerting a pressure on you. But we have always felt that pressure, and so we don't even notice it. At sea level, on the Earth, the pressure of the gas molecules in the atmosphere is 14.7 pounds per square inch. The other way to abbreviate that is PSI, and that's the same unit that they use on tires. So if you're filling up the pressure, your bike tire or your car tire, it's in PSI. There's this other unit, newtons per square meter. That's more of a physics unit, and we really don't care about that right now. Don't tell the physics people. So what happens? Here's a picture of the orange soda. So when the straw here is open to the outside, the pressure inside the straw is equal to the pressure outside the straw, right? When you put your mouth on the straw and suck some of the air out, now the pressure inside is lower and the pressure outside is greater. And that causes the soda to move up into the straw until the pressure is equal inside and outside. That allows the water or the liquid to go up. Well, atmospheric pressure is not infinite. It's 14.7 pounds per square inch. That's what the atmosphere is exerting. That can only support a column of orange soda that's about 10 meters tall. Beyond that, even if you have a perfect vacuum here, there's not enough pressure pushing down to push the soda up any farther. And so you can't suck soda up through a straw longer than 34 feet. So, if you're planning to do that this weekend, I'm sorry. But you can't make a straw where you could put a glass of soda on the floor and stand on the roof of the building and be able to drink soda. It wouldn't work. Somebody might be tempted to try that. Could be fun.